samples. And look here, the median of the first sample is 5 and the median is 7 here. And also we found already Q1 and Q2 and Q2, and we noted that the box of this data is longer than the box of Jonas data set. So Finn can say that his data is more spread out, has greater variability. Now let's go to the second example. In the second example here, who can read the second example? Students, please concentrate. Here we have two box plots again. Finn and Jonas analyze and measure the center and and variability of the data they collected. Do these measures support Finn's assessment of the two data sets in example one? In example one, look here, Finn's look here. Finn can say that the median of Jonas data set is greater, and also Finn can say that his data is more spread out, or a greater or has a greater variability. Now we want to see if we can support that or no from the measures that we have using the box plots that we have. So here we have the box plot for Finn's data set. This point again represents the minimum data value that we have, which is 1, and here we have the maximum data value that we have, which is 11, and this point represents Q1. Students, concentrate. This is Q1, and this is Q2 or the median, and this is Q3. So here, this is Q2. 50% of the values are less than this point, and here 50% of the data values are less than this point. So the median of the first data set is 5. Look here, and the median of the second data set is 7, and the first quartile, or this point here, or this line here, 3.5, and the third quartile 6.5, which is correct. Yes, yeah, correct. And the first quartile for Jonas data set is 5.5, which is correct also. Look here, it's 5.5, and the third quartile for the second data set is 8, which is correct also. And we can use the first and the third quartile to calculate the interquartile range. Again, the interquartile range can be calculated using this rule, Q3 minus Q1. It is a measure of variability. Okay, Q3 minus Q1, it's 3. It's 6.5 for the first data set. 6.5 minus 3.5, so it gives you 3. Yes, this is for the first data set or Finn's data set. Finn's sample, and IQR. Now what about Jonas data set? The IQR again, interquartile range, again it's a measure of variability. The IQR is equal to 8, which is Q3 minus 5.5. So it gives you 2.5. And here the median is already calculated. We found it already. So the median of Jonas data set is greater. It's 7, and the median of Finn's data set is 5. So we can say that the median of Jonas data set is greater. So the students at Jonas school generally spend more hours on homework each week than the students at Finn's school. And this is the way how you can make inferences depending on the measure of center or the median. and the interquartile range or IQR of Finn's dataset is greater. It's a 3. Look here, it's a 3, which is greater than the interquartile range of Jonas dataset. So the variability here, or the spread out, is the number of the students in French school spend on homework. So there is a great variability or spread in the number of our students in French school spend on homework. So you can use box plots to find the interquartile range, to find the median, and then you can use the measures that you found to compare between data sets. And here we have another example number 3. Who can read it, please? Munir, Abdullah, any one of you? Khalid, Muhannad, any one of you? Who can read example number 3, please? Mr. Johnson and had students grow the same type of plant in 2 different rooms to test the growing conditions. The box plot shows the height of all
Can
plants. Yes, please. Thank you.
Mr. Benson had students grow the same type of plants in 2 different rooms to test the growing conditions. The box plots show the height of all the plants after 3 weeks. How do the two populations compare? What inference can be drawn?
Thank you. Do you understand the question?
Yes,
Okay. So please, could you please tell me the median? Here we have 2 groups. This is the first group for the first room. Here, room 7D, like 7.1 or 7.2. Maybe this is 7.4, and 7D or 7.5 here. We have 2 samples. Okay. Now, if I told you this, the, for these 2 samples, what is the mean of the first sample? The median, sorry, the median of the first sample. The median represented by this line. What is the median? 12. Here, first sample is 12. This is the median. What about the second sample? Also, it's 12. Look here, it is represented by this line. So the median here is also 12. Do you understand it?
Teacher, I
yes,
didn't understand.
Sorry?
I didn't understand it.
You didn't understand it. Okay. Here we have 2 samples and 2 graphs. Are you with me till now?
Yeah.
This line represents the median.
Yes.
So what is the median
12.
of the heights here?
12.
12. 12. Excellent. And what is the median of the heights here? Also, it's what?
12. Yeah. It's also 12.
Excellent. So the medians are 12. So the median heights are the same. So this graph represents the height in inch for the plant they grow. So here the median is 12. The median is 12. What do you mean by the median? Do you know what do you mean by the median? If I told you you have those marks, 10. Let's say that we have those marks. Let's say that we have 7, 8, 8, and 10. If I told you that the median is 8, what do you mean by the median is 8? Median is 8. Do you
That
know?
the number that is replayed.
No.
Huh.
I tell you, 8, the median is 8, means 50%. 50% of the data values that I have is less than 8, which is correct. 8, it becomes here. How to calculate the median, if you remember? Look here. Remove this 7 with this 10, and you have 2 numbers, add them, then divide them by 2. This is the way how you can find the median. Okay, so 8 plus 8, 16 divided by 2, it gives you 8. So the median located here. It means that we have 50% of the data values less than 8. This is the 8 that we have, or this is our median. Okay, so what do you mean by 50% of the data values that we have is less than 50, less than, sorry, 8? We have 2 data values less than 8, and we have 2 data values above 8. And here, 50% of the plants in 7D, okay, are less than 12. So this point represents the point at which 50% of the data values are less than. So here at this point or less on the heights of the plants in the first data set is less than 12, 50% of them. And here we have 50% less than 12 also in this data set. Okay, and this is what do we mean by the median. Again, median is very important. It gives you the point at which 50% of the data values
Teacher,
is done. Yeah,
thank you. I understand, but can you give me more example to do it?
I'll I'll give you. Let's continue this example, and
Okay.
you will do the next example. Okay.
Okay.
Now this represents the median. If I told you what is the first quartile,
What?
what is the first quartile?
Your voice is lagging, teacher.
First first quartile. Do you know what do we mean by the first quartile?
What's mean that?
I tell you. The first quartile is this one. So what is the first quartile in the first data set?
8,
8. Excellent. And what is the third quartile?
16,
No. This the
14,
first
14.
14.
Yeah,
So here we have 14 and here we have 8.
8.
So this is a Q1 and this is a Q3. We already finished talking about Q2. Q2 is the median. We finished. Yeah, we finished talking about it. We
Yeah,
said that 50% of the data values based on that point. What do we mean by Q1? 25% of the data values is than 8. 25% of the data values less than 8. And what do we mean by Q3? 14. 75% of the data values less than 14. Understand it? So we have 3 points in the box plot. We have Q1, Q2, and Q3. Q1, it means that 25% of the data value is less than Q1. If you have data values, let's say that we have many data values, okay? 25% of them are less than 25, are less than Q1, okay? Do you understand it? Do you understand what do I mean?
yes, teacher, yes.
And the Q2, 50% of the data values are less than Q2. And 75% of the data values are less than Q3. Okay? I told you you have these data values. Please concentrate. Okay? I'll
Yeah.
give you an example. Let's say that we have these data values 1, 2, 5, 7, 9, and let's say 11. Okay? If I told you construct, look here, the question, construct a box plot, how to do? The box plot looks like this. This is our box plot. It looks like this.
Yes.
So we need 5 points to identify. This is the first point. This is the second point that we have to identify. This is the third point. This is the fourth point, and this is the fifth point. This represents by the minimum value that we have. The minimum value here is 1. Okay,
Yes.
and this is the maximum. So the maximum here is what?
11.
11. Okay, now we need Q2 and we need Q3 and we need Q1. Okay, are you with me?
Yes, yes.
So how to find the Q2? Just find the median.
7.
The median of the 7. Let's try. Remove this with this and 2 with 9. So we have 2 values. If you have one value, you can take it. If you have 2 values, what you have to do? Add them. 5 plus 7, then divide them by 2.
Yes.
So 12 divided by 2, it gives you 6. So what is the value of Q2?
6.
6. What do you mean by that value?
Uh,
50%.
yeah,
It is
50.
located
Yeah,
here.
50%. Yeah.
This is a Q2. This is Q2, which is equal to 6. We calculated already, yeah? This is 6, okay? 50%. We have 6 data values here. Look here, we have 6 data values. 1, 2, 3, 4, 5, 6. 50% of the data values are less than what? Less than 6, which is correct. We
Yes.
have 3 values less than 6. So 50% of the data values less than 6. Do you understand it?
Yes.
Now, we already found the Q2. Now, let's find the Q1. How to find the Q1? Here we have two groups, this group and this group, okay? Find the median of this group. How to find the median of this group? Just remove this point with this point. We have one value. So what is the value of Q2?
2.
Excellent. And
Q1 you mean?
Q1, sorry. And the Q3, what is the value of Q3?
It's
Remove this point with this point.
it's 9.
9. Okay? So we have Q1, we have Q2, we have Q3. What do we mean by Q2? 50% of the data values
Yes.
are less than Q2. And here, what do you mean by Q1? 25% of the data values are less than
2.
Q1. And here, Q3, 75% of the data values are less than 9. Okay? Do you understand it?
Yes.
So we have the box plot. You have the box plot for this data value. Now, if I told you, look here in the example, let's take the example or the question here. A
Yes.
local recreation center offers a drop-in exercise class in the morning and in the evening. So this, we have two groups here, in the morning and in the evening. Okay, can you see my screen?
Yes.
We have two groups. This is the first group and this is the second group. Now the attendance data for each class over the first month is shown in the box plots at the right. What can you infer about the attendance? Class attendance. Look here, the median here is what? 4 and 5, 4.5. And
4.
the median here, what is it? Yeah, here the median
6.7.
6.5.
How?
In the middle of the distance between 6 and 7 is 6.5.
Yeah.
Nearly, yeah, 6.5. Yeah. So, what do you think? The students prefer to come in the evening or in the morning?
In the morning.
The median is this.
In the evening.
The evening.
Yeah.
In the evening. So 6.5 because this represents the median. So I think that the class attendance in the evening is more than the class attendance in the morning. So they prefer to come the evening. Okay.
Yes.
So depending on the median here that I can get from the plots, I can infer about the population that I have. Okay. So depending on the results that I can get from studying box plots, I can infer about the populations. Now, this is about the median. What about the interquartile range? Again, let's return here. We have Q1, Q2, and Q3. Okay. How to calculate the IQR? IQR. What do you mean by IQR? Do you know what do you mean by IQR? Interquartile range. Interquartile range. It is very easy to calculate. It's Q3 minus Q1. So what is the IQR for these are the values?
We added
It's a Q3 minus Q1.
Q3 minus Q1
What's the value?
is 7.
9. Excellent. Minus 2. It gives you 7. So this measure, the IQR or the interquartile range, gives you the something called a measure of it is a measure of variability. What do you mean by a measure of variability? Okay, I'll tell you the IQR is 7. Okay, don't forget that. If we have two data values, let's say that we have a class of 20 students. Okay, let's say that we have a class of 20 students,
Yeah.
and their marks in quiz 1 looks like this. Look here, concentrate with me. We have a mark 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's say that the marks in the first quiz looks like this. Here we have 3 students got 7. We have 5 students got 8. We have also 5 students got 9, and we have 3 students got 10. 1, 2, 3, 4, 5, 6, 7, 8. We have 10, 16, and let's say that we have 1 student, 10 students. So here we have 20 students, and their marks looks like this. Okay, look here, their marks. And let's say in the second quiz, the marks looks like this. Here we have 2, we have 3, we have 4, we have 5, we have 6, we have 7, we have 8, we have 9, and we have 10. Let's say that the marks looks like this. 1, 2, we have 2 students here. Look here. What do you notice about this? The variability or the values are here are spread out. Look here, are spread out. Okay, and look here, the data values are clustered here. If you calculate the mean, maybe the mean here is 8.5, maybe. Okay, and maybe the mean here, can you hear me? The mean here is 5.5. So the data values here are spread out, and here, look here, it is clustered about the mean. So here we can say, maybe if we calculate the IQR here, maybe it gives you 3, and here maybe it gives you 7. So here the IQR gives you a measure of variability. So the variability here or the spread out here is more than or greater than the variability here or spread out here. Do you understand it, Muhammad? It is far from the mean. Here the data values are far from the mean, and here
Yeah.
very close to the mean. So if you calculate the IQR here, maybe it gives you 7 IQR.
Yes.
Maybe it gives you 7, and maybe if you calculate the IQR here, it gives you 3. What do that mean? As I told you, IQR is a measure of variability. Why it gives you 3? Because the data values are very close to the mean or to the median. And here, look
Yes.
here, the IQR is 7. Why? The data values are far from the mean, which is calculated 5.5. So as you can see, the IQR gives you the variability or the spread out of the data values that you have. Okay. So this is the way how you can use the IQR and the median to compare between data. And here the distance from here to here, from this point to this point, gives you the IQR, and here we have IQR. We have same IQR here. So while the median heights of the plants are the same, the median heights, look here, it's 12 for both data sets, and also the IQR the same. Here we have 6 and 6, but look here, it seems that you can infer that the growing conditions, the rule 7G, are more favorable for growth than room 7D. Why? Because 50% of the plants here, plants height, um, are between 10 and 16. The plants height. And here 50% is in between 8 and 14. So we can infer that the growing conditions in room 7G are more favorable for plant growth than 7D. And here, what you can infer it's easy. You can infer that most students prefer to attend evening, attend evening as evening. So this is about this lesson. Students, please concentrate, and please, if you have any question, please raise your hand. Now, as a key concept, look here, you can use data displays such as box plots to make informal comparative inferences about two populations. Here we have two data sets. The median here is
Teacher,
5 and the median, yeah, yeah,
can you back 1 minute?
where here?
Yes, the page.
Yeah,
It's only I pictured.
okay,
Yes, teacher, I finish.
okay. Okay. And here we have two data sets again. The medians here, the median here is 5 and the median here is 5, but the IQR here is 7 minus 4, 3, and the IQR here 9 minus 4, it gives you 5. So the IQR is here more than the IQR here. Okay, so the length of the box, the IQR for data set B is greater than the length of the box, the IQR for data set A. So data set B has a greater variability. It is easy to identify because here, look here, the length of the box here is greater than the length of the box here. So the variability in data set B is more than the variability in data set A. Now, here we have questions from practice and problem solving. Who can read and answer this? Yes, please. Who can read, please? Any one of you? Yes, please. Anyone? Here, water pools at lower temperatures are as elevation increases. Rob and Anne um, live in different cities. They both boil the same amount of water in the same size. Plan and repeat the experiment the same number of times. Each records the water temperature just as the water starts to boil. They use box plots to display their data. Compare the medians. Just compare the medians. Here, look, we have the median, and we have here the median. Okay, the median is 207 here. Look here, the median is 207, 205, 206, 207. So the median here is 207, and the median here is 207.1, 207.1 for this data set and for this data set. So the median of Rob's data is 0.1 degrees Fahrenheit greater, not greater, lower, sorry, lower, lower than the median of Anne's data. So here at a higher elevation. Now here we have question number 7 also. The median of animal. Who can answer this, please, students? Animal 2's data is, what is the median of this? It's easy. 2 is greater than. Look here, the median is 25.8, and here the median, maybe it's 25.7, so it's greater than. And this infer that there is less variability because the width here in the data class of animal 1 than the animal 2, because look here, the width here is less than the width here. So we can say that this can infer that there is less variability in the data. So this can also infer that animal 2 generally eats more food. And here also we have another question, question number 8, that is about the median. The median here for tree 1 is greater. The median, look here, it is about 27. The median here is about 17. So the median height of tree 1 is greater. So this is about this lesson. It's a very easy lesson. You have to identify 5 points. You have to identify the minimum point, the maximum point, and you have to identify Q1, Q2, and Q3. You have to identify IQR, the median, and you have to know how to interpret box plots, and how to use the information that you can get to infer about the book. Okay, do you understand it? Students, if you do not understand, please again raise your hand. Okay, this lesson is in your final exam. Please try to write the answers. Okay, and please, if you have any question, please tell me. You have 2 minutes to read and write the answers. Okay. So students, again, if you do not understand any of these questions, please tell me.
Teacher, I don't understand the lesson very well.
Okay, which question?
The lesson, all of it.
Look here. Look here. Let's go to question number 8. Can you see question number 8? Can you see it?
Yes.
It's a very easy question. What is the median of 3-1?
What?
The median, the median. This line represents the median. What is the median of 3-1? It's approximately 27 or 28. Maybe it's 28. Look here, it's 28 or 29. We can say it's 28, yeah?
Yes, yes.
And what is the median of the height of 3-2? It's about what? 17. Excellent, 17. So which is greater? The height
20,
here, 28 or 17?
28.
So the median height of 3-1 is greater.
Okay. Like this, the lesson.
Yeah. It's just to identify the median and to identify the range. Look here. Let's go to this question. Let's go to this question with no answers.
Yes.
Look here. We have 2 data sets. We have this data set and we have this data set. What is the median of this data set here? The median here. What is it?
Uh,
25.7, I think.
Yes.
It's between 25.6 and 25.8. Maybe it's 25.7. It looks like to be 25.7. What is the median of the second data set here?
25.8.
25.8. So which is greater? Here, the
25.6.
median of animal 2's data is what? Greater.
Animal 2, animal 2.
Yes. So it's greater.
Yeah.
The median is greater than the median of the animals animal 1's data. So it's greater. 25.8 is greater than 25.7. Now here, this can infer that there is the variability, as I told you, it depends on the width of the box. It depends on the width of the box. So here the width, look here, the width looks like this, and the width here is more than. So here the width is greater than the width here. Can you see it? Can you see that? The width of the box. here in animal 2, the width here is greater than the width here.
Yes.
So if you have a greater width, so you have a greater variability. So this can infer that is less.
Less.
Excellent. Less variability in the data of animal 1 than for animal 2. It depends on the
Yes.
width, because here the width of the box here is less than the width of the box here. Okay?
Yes.
And look here, this can infer that animal. It depends on the location of the box. Look here,
Yes.
on average, 50% of animal 2 data set, or in animal 2, in the data set 2 here, animals in the data set 2, eat from 25.6 to 26.2, and 50% eats from here in animal 1 set, eats from maybe 25.5 up to 20. So who eats more? Oh, what do you
Two.
think? Tuso can infer that animal 2 generally eats more. Is
Yes.
it hard?
No.
Very easy. Okay,
Thank you.
you are welcome. So this lesson, and also we have this. Also, this is the median of the first. Look here. This is the median of the first. This is the median of the first box plot is 207, and this is the median of the second box plot is 207.1. So the median of Rob's data, or the first data set, is 0.1 degrees Fahrenheit. The difference between them 0.1 Fahrenheit lower than the median of Anne's data, and this means that Rob is at a higher elevation than Anne. Students, again, if you do not understand, I'll explain to you again. Okay, a very easy lesson. Okay, please try to write the answers. And if you have any question about any of these questions, please tell me. I will explain it to you again. Okay, students. So again, this video or this lesson is in your final exam. So please concentrate on that lesson. And if you have any question, please tell me. I will explain it to you again. And also, you can see this lecture again another time. And if you have any question about this lesson, I will explain it to you again. Okay. So our period is finished now. This video lecture is already recorded. It will upload it to your Coursera account. You can see it again if you want. But please, if you have any question, please tell me. I will answer you. Okay. Thank you for all of you. See you. Assalamu alaikum wa rahmatullahi wa barakatuh.